What's up, guys? It's Mr. Brengle, and today we're going to be talking about the voltage, current, and resistance concept builder from physicsclassroom.com. It'll say current, the equation current is equal to delta V over R. Equations to guide thinking, I believe is the title, but it also might say Ohm's law concept builder. So what we're going to do here is we're actually just going to jump right into the master level and then the wizard level and skip apprentice, because apprentice and master are the same thing, but master's got more questions. So we'll do 3 or 4 questions on the master level, and then we'll do a few on the wizard level as well, which does add a different dimension to this. So we're going to go ahead, we'll read the question, then I'll kind of talk about what we're going to do. So it says the current in the wires of a circuit is 60 milliamps. If the voltage impressed across the ends of the circuit were tripled with no change in the resistance, then the new current would be, and then that's what we're solving for. So for this, the thing is that you have to understand the equation, right? So current is equal to voltage divided by resistance, okay? And because of this, since voltage is in the numerator, whatever happens to the voltage will happen to the current. They're directly proportional, meaning that if you, in this case, triple the voltage, it would also triple the current. So if this becomes times 3, then this over here is times 3. You'll have to forgive my handwriting today. My stylus is out of battery, so we're just using the old finger. So, and vice versa, if the voltage is divided by 3, then the current would be divided by 3. And we can show this with an equation, a very simple equation. Let's say that like 10 over 1 is equal to 10, right? So if the voltage was 10 and the current is therefore 10 with the resistance being 1, let's say I cut that 10 in half. And now it's 5 over 1 is equal to 5. So I cut the voltage in half, and then the current also gets cut in half there. So that's the whole point with voltage, is that it's directly proportional to the current. And then resistance is in the denominator. So with the resistance, it's actually going to be opposite, right? So like current and resistance are inversely proportional, meaning that if resistance goes up, then current goes down. If resistance goes down, then current goes up. So if I were to multiply the resistance times 2 and make it larger, then my current would be divided by 2. Whoops, I wrote a B there because I was saying the word by. So anyway, we'll go ahead and rewrite that a little bit better there. So if I multiply the resistance by 2, I would divide the current by 2. If I divide the resistance by 2, I would multiply the current by 2. So it's opposite. And hopefully that makes sense. Now, what we'll do here is we'll just kind of go through these. So if the original current is 60 milliamps, right? And honestly, you can write the equation out if you want to. So you could write 60 is equal to, and then just make this 60 over 1, right? Simple equation. Obviously, the resistance is not changing here. It says that, so we don't have to worry about it. Now, it says that the voltage is tripled. So what that means is if I triple the voltage, which is the 60 in the numerator right here, it becomes 180 over 1, and that's equal to 180. So our new current here would be 180 milliamps. And let me go ahead and erase this here so we can use that. So the new current is going to be 180 milliamps, and we can go ahead and check our answer, and it should be good to go. So we'll go ahead and do just a couple of these problems here, and then we will move on. So this time it says the current in the wires of the circuit is 180 milliamps. So here's our current. If the voltage impressed across the ends of the circuit were 1/3. So 1/3 of the original value. So we're dividing the voltage by 3. So again, we can make an equation here. We can say the voltage, which is 180 over the resistance, let's just say it's 1, doesn't matter what it is equal to 180. Well, if we cut the voltage in 3, 1/3 of its original value, that would now be 60 over 1. And then that's going to be equal to a new current value of 60 milliamps. So we'll put that in, enter it, check our answer. Bada bing, bada boom. All right, good to go here. So get rid of all this up here. We'll do one or two more. I want to get one with resistance here. So it says the current of the wires in a circuit is 120 milliamps. If the resistance was reduced to 1/3 of its original value, then the new current would be what? So on this one, you've got your current is 120, okay? And you can, we could just keep doing the same thing, do 120 over 1. Well, if we reduce the resistance to 1/3 of its original value, the new equation would be 120 divided by, this would be 0.3 repeating. It's hard for me to get a point in there. I'm trying to put a dot in there. That's pretty bad. So 0.3 repeating, which is, a little bit, maybe you don't want to deal with a fraction or whatever, but you could also just put it in as 1/3 and then multiply by the reciprocal. What you're going to find is that because the resistance went down, the current goes up. So if you divide the resistance by 3, that means we need to multiply our current by 3. So the new value here is going to be 360 milliamps because you can go ahead and do that calculation if you like. But that's what we're going to put in here is 360. Go ahead and enter that, check the answer, and we are good to go. So let me see. We'll get one more maybe if we got a resistance one here. Yeah, we've got another resistance one. So the current of the wires is 180 milliamps. If the resistance of the current was tripled, what would the new current be? So we've got our initial equation would be 180 is equal to a voltage of 180 over 1. Doesn't matter what numbers you use here as long as it equals 180. Now it says that the resistance is tripled, so we leave the voltage the same, 180. We triple the resistance. So since we're multiplying the resistance by 3 and it's inversely proportional with the current's going to get divided by 3. And that's what we're seeing here. And so our new value here is going to be 60 milliamps. So we'll go ahead and put that in. Okay, great. So what we'll do is I'll go ahead and let you guys finish those off on your own. And what I'm going to do is I'm going to go back to the main menu. And we're going to go to the wizard level because the wizard level involves changes to both the resistance and the voltage in a lot of these cases. So this says that the current in the wire is 60 milliamps if the resistance of the circuit were cut in half. And this one says no change to the voltage. So I do want to find somewhere we do change the voltage. But so resistance was cut in half, which means we're going to double the current. So this is going to become 120. This one says we've got a current of 120 milliamps. Voltage is 1/3. This one, of course, didn't give us the double change here. So voltage is divided by 3. Since that's in the numerator here, that means that the current will also get divided by 3. So we're going to end up with a new current of 40 milliamps. And we'll just keep going until we get one where they change both. So 60 milliamps, voltage is doubled and resistance is 1/3. Okay, so here we go. So the voltage here is going to be doubled. And then the resistance is going to be divided by 3. I apologize. I'm going a little crazy here trying to write with my finger. Okay, so you're just going to consider these two changes independent of one another, right? So basically, we have an initial equation that's 60 is equal to, let's do this. Let's do 180 over 3. Okay, that'll make this nice and easy. So the changes that we're making here is we're multiplying the voltage by 2. Okay, so we're going to have 360 in the voltage in the numerator here. I don't know if it helps. Maybe we put the symbols here. And then it says that we're going to cut the resistance to 1/3 of its original value. So instead of it being 3, it's now going to be 1 ohm. And so you can see here that this is going to make a new current of 360 milliamps. Wow, that was supposed to be an M. 360 milliamps. So basically what you can do is you can do this in two steps. You can say, okay, voltage is multiplied by 2. So I'm going to go ahead and multiply my answer by 2. So it gets up to 120. And then divide resistance by 3 means that we would multiply the current by 3. So 120 times 3 is 360. So you can either just do the equation like this, kind of set this up, or you just do it step by step. Do this part first, multiply your current by 2 because voltage got multiplied by 2, and then multiply current by 3 because resistance, or the new current that you've got after you multiplied it by 2, multiply it by 3 again, since resistance was divided by 3, and then you're good to go. So we'll go ahead and plug in 360 here and check our answer. I'll go ahead and erase. And then hopefully we can go ahead and get one more of the double change here. We'll see what we get. 120 milliamps, resistance is doubled, so that's, and nothing to the voltage, so that's going to cut our current in half. So it is going to be 60 milliamps here. I'll try to get one more that has a double change. Yes, okay, we've got one here. So current of the wires is 60 milliamps if the voltage is doubled and the resistance is tripled. So voltage is multiplied by 2 and resistance is multiplied by 3. So we've got, we can set up a simple equation again. So we'll say 60 milliamps. I'm just going to put an A for amps here because I'm having a hard time writing the lowercase m, is equal to 60 volts over 1 ohm. And then in our new equation, we would rewrite that. We would multiply the voltage by 2, so now 120 volts over, and then we multiply the resistance by 3 ohms. And we can see here that that's going to give us an answer of 40 milliamps. Okay. Now, again, you can do this by, okay, start with 60, multiply it by 2 because the voltage was multiplied by 2, so we're up to 120. Then because resistance is multiplied by 3, we need to divide that number, the new current, by 3. So 120 divided by 3 is 40. So whatever way makes more sense to you. And we'll hit enter there and check our answer. Okay, great. So right there, we've gone through basically every type of problem on here that you can run into. So I'll go ahead and leave you to complete the rest on your own. And that is your Ohm's Law Concept Builder. Please make sure to let me know if you have any questions.